In this example, we'd like to match the correct exponential regression function given a table of data. So let's look at our data for a moment. We see x is increasing from 1 to 5, and we see y is starting at 74.8 and ending at 24.4. So the first piece of information that's important to get from this table is the fact that we've got what we call exponential decay happening here. And we know that because my values are starting high and ending low. What that means is when we look at the general form of an exponential function, exponential decay occurs when the value of b is between 0 and 1. So if I compare that notion with the four choices I'm given, then I'm looking for something that uses a value between 0 and 1 as the base of my exponential. So that means I'm not going to be using b, because 1.6 is bigger than 1. I'm not going to be using d for that same reason. So now I'm between a and c. The next important piece of information would be to look at the y-intercept. If I look at ab to the x, and I wanted the y-intercept, that means x is 0. So really the y-intercept is equal to the value of a, or the value in front of the power. When x is 0 here, I have a y value of 74.8, which is almost 75. Out of the two functions that I have left, a and c, only one of those is close to that value of 74.8, and that's the 75 we see in a. So we could rule out c, and the function we would need to model this data would be y equals 75 outside of 0.8 to the x, or a.